Thomas Kochen, former NASA science director, reflected on the launch of the James Webb Space Telescope, JWST, marking it as the onset of a new astronomical era. He stressed JWST's pivotal role in broadening and scrutinizing our cosmological understanding, especially regarding planets and the origins of life. However, what began with hopeful anticipation quickly turned into a debacle. JWST's launch startled scientists, triggering crises and igniting debates within the realm of physics, questioning long-standing theories and the validity of existing comprehension. The discourse over correctness or fallacy seems to be reaching a temporary conclusion, prompting inquiries into the enigmatic revelations JWST has made possible. Initially anticipated to offer solutions, JWST's $11 billion initiative instead plunged cosmology into a significant crisis reminiscent of historical shifts in scientific paradigms. This upheaval challenges the very bedrock of modern physics, hinting at potential deficiencies in our comprehension of the cosmos. Astrophysics, rooted in ancient and medieval physics, confronts a quandary as our observations surpass the boundaries of current explanatory models. The crisis deepened with conflicting measurements concerning the universe's age and expansion rate, known as the Hubble tension. JWST's detection of highly evolved galaxies has cast doubt on the universe's presumed age, conflicting with established cosmological theories. This dissonance disrupts the notion of a universe evolving from a Big Bang 13.8 billion years ago. At this crossroads, we must reconsider our assumptions about the universality of earthly physics. Perhaps, as the ancient scholar Hermes Trismegisto suggested, the physics of the cosmos may reveal forces and dimensions overlooked on Earth. JWST's breakthrough technology, capable of detecting faint light signals from galaxies formed shortly after the Big Bang, highlights the telescope's significance in reshaping our understanding of the universe. At the same time, a bitter disappointment arises when, instead of baby galaxies, the Webb shows perfectly developed galaxies that appear to be several billion years old but with an age of 13.5 or 13.6 billion years. This can never be the case. These days, scientists sometimes say that the objects and the images are, quote-unquote, impossible or not real. But well, we can only show us the truth. Science must now admit that it has probably been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see here is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with the new truths. Some of the old traditionalists who don't want to look at the new truths in the face vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, it also took many years before the Church was finally willing to admit that the Earth was not the center of the universe, even though there was suddenly masses of evidence from astronomers all over Europe. So not much seems to have changed, and although we consider ourselves much more modern today, we have a similar scenario. Researchers who proclaim something new may no longer end up in prison like Galileo Galilei, but the quarrels between researchers and the hostility towards new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tell a different story. Perhaps your mind would also rebel against this at first, and it would take a while before you could accept the new truth. As everywhere, there are some who are quicker to adapt and others who take longer. Many open-minded and young scientists are enthusiastic about Webb's discoveries. Rohan Naidu, the discoverer of the Glass C11 galaxy, and Ste Finlin, who discovered Massey's galaxy, belong to this open-minded generation of researchers. They look at Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasize several times in interviews that we simply cannot know what will happen in astrophysics. At this moment, we have to wait for further measurement results, studies, and of course, Webb's latest images. Was it Hubble's fault? Let's take a look at the debacle. One of the great debates in modern cosmology concerns the Hubble constant. This is the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded upon, and the Belgian astronomer Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we already know from alternative methods that the movement of galaxies can also be explained differently, and these approaches also provide a coherent picture in their entirety. However, they were ignored for a long time because the old theories were considered more probable. But the more we see of the universe, the more discrepancies emerge. This didn't just start with Webb. Even 20 years ago, there were regions in space where the expansion was behaving differently. It was as if these regions were sometimes faster and sometimes slower, or perhaps denser or emptier. This led to speculation that there may have been several starting points, or that our universe is even permanently fed by several sources, which do not necessarily all have to have had a beginning at the same time or at all. Alternative ideas about the shape, nature, and age of the universe emerged once again, but researchers continued to cling to the old theories of the Big Bang and expansion. This was possibly stake. We have already briefly learned about the Hubble tension. In short, it shows clear differences in distance measurements in the universe depending on which fixed points we use as measurement constants. Now scientists hope that the Webb telescope, as its mission progresses, will be able to resolve this tension by making precise measurements of the distances and red shifts of galaxies. This could correct errors in previous measurement methods and pave the way to a new advanced physics. Ultimately, researchers have exerted their utmost efforts to unravel explanations and theories, significantly advancing humanity's understanding of the cosmos. Instead of dwelling on guilt, our focus should be on embracing every new discovery, even if initially unfamiliar or startling. With the surge of new theories and alternative explanations, we likely stand at the thrilling dawn of a new era in science. Revisiting the oldest celestial bodies could unveil whether they are accretion disks or jets of supermassive black holes, reshaping our cosmological understanding and potentially highlighting the pivotal role of black holes in universe discovery. One such theory, pioneered by British scientist Roger Penrose, posits a universe perpetually recreating itself in cycles, with black holes potentially enduring such transitions as vast repositories of information. Despite Penrose's groundbreaking work predating the Internet, its acceptance is now gaining momentum, marking the nascent phase of a transformative mission. With the unveiling of a second deep image, coupled with the discovery of an ancient, expansive structure defying the confines of a youthful universe, the evidence continues to mount, awaiting further revelations from the telescope. Beyond delving into the origins of the cosmos, the telescope tirelessly expands our knowledge of exoplanets, uncovers new worlds, illuminates our solar system, and captures intricate details of the cosmos' grandest structures. Each observation contributes a piece to the overarching puzzle. Even measurements from exoplanets enrich our understanding and offer vital clues to previously undiscovered phenomena. Our scientists diligently seek the parameters and structures of a fundamental matrix, propelled by the revolutionary impact of the telescope, sparking contentious debates yet fostering hope that the ensuing crisis may inch us closer to truth. If you enjoyed this video, be sure to give it a thumbs up, share it with your friends, and subscribe to my channel for more content like this. Thanks for watching.